Hi, today I will be demonstrating our AI Minecraft bot that is trained for several thousand iterations. The goal of this project was to create a competent opponent from scratch, using the Q-learning technique from reinforcement learning. Creating a bot capable of challenging the player is no easy feat, and the size of the Q table that is being generated requires several thousand iterations to start producing behavior that is clearly not random. In order to make this problem more manageable, we impose several constraints on the environment. Our bot and his adversary are equipped with a shield, an iron sword, and a single health potion. Enclosed in a flat 6x6 arena, the simulations are sped up 500-second brawls between the opponents. The actions each agent is capable of are swapping between the sword and the potion, moving in the cardinal directions, and either left or right-clicking the mouse button. This translates into either blocking with the shield, attacking with the sword or potion, and drinking the potion. In this version of the program, the agent automatically attracts his opponent. We'll discuss issues with allowing free-form turning in a moment. On top of this, regeneration has also been disabled, as health is an important metric for the reward function. Even in this restricted scenario, presenting the unfiltered state the bot sees every cycle would create a massive table, which would subsequently take much more time to learn. Instead, we've decided to restrict the set of features that convey important information to the agent. It knows, for instance, how far away the enemy is, roughly the angle it must turn to face the enemy, whether or not they could land a hit or could be hit, if they drank their potion already, and if they have high or low health. This is effectively all the agent sees and all that they can learn from. At first, we pitted our training against an opponent who constantly would swing its sword and move and rotate in random directions. It did not do well. After several hundred iterations, the agent still had difficulty tracking the enemy and had a win rate of about 26%. It became clear that allowing the agent this freedom of rotation was too granular for what we wanted, and forcing the agent to always track led to much more promising results. After a few hundred iterations, it was at 86%. The original scope of this project, however, was to make the AI fight against itself, and that's exactly what we did. The enemy in this scenario has one version of the Q table which is static, so the enemy acts deterministically. The player still updates their Q table and maintains the chance to act randomly. If the player wins the fight, the agent swap the tables, the idea being that the enemy always has the Q table which has been improved from the fighting. This was when some truly interesting behaviors started emerging. Suddenly the agents acted a lot more cautiously, holding up their shields more and keeping their distance before moving in with a fury of blows. They started using their potions more reliably and timing their swings to maximize damage. After 500 iterations of this kind of training, we once again put the agent against a random opponent. The win rate was 95%. Overall, we are quite happy with these results, but could imagine further improvements by adding more features and tuning the reward function.